Okay, what about that electron C model? Metals have really low ionization energies. So what happens in a metallic solid is each metal atom donates valence electrons to an electron C. We talked about this a little before. I think of that as the moms sending the little electron boys out to play, and they're just running around the neighborhood. So we can think of metal, like sodium metal, as being an array of sodium ions surrounded by this sea of negative electrons. And so the sodium ions get held together by that sea of electrons that surround them. This explains the conductivity of metals, because those electrons, the electrons in this sea, they're not stuck to a particular atom. They're free to move around. Like little boys in the neighborhood, they just wander all over the place, right? So that explains conductivity, both of electricity and of heat. And it also explains malleability and ductility, because these are non-directional attractions, and so you can deform the metal, hit it with a hammer and dent it, and it'll just deform. It won't shatter. Any questions? This is kind of interesting. There's you've probably heard a lot about the ozone layer, but then there's greenhouse gases too. And so the ozone layer is important. Oxygen has a double bond. Ozone, we just saw, we drew a resonance structure. It actually has a bond that's between a single and a double. So its bonds are weaker. So what happens is, up in the outer atmosphere, we've got UV light from the sun comes in, and that light has enough energy to break this weaker bond in ozone, this 1.5 bond. It's not strong enough to break the oxygen-oxygen double bond, but it can break that 1.5 type bond in ozone. And so when it does that, that reaction absorbs the energy. So ozone decomposing or being broken down into oxygen and an oxygen atom filters out a lot of the UV light. Well, the UV light is absorbed because this bond is weaker. So we've got oxygen-oxygen double bond, and then in ozone we have this weird kind of 1.5 bond. So this bond is weaker, and this bond is stronger. This UV light is more energetic than visible light. And so the UV light has enough energy to break one of these bonds. And so it can, and it does. So it'll break this bond, and then that absorbs the UV light. And so it doesn't pass through and come down and give me a sunburn. Now, the ozone layer does not absorb all the UV light, but it absorbs some of it. So that breaks up the ozone. Well, then what happens to the ozone? Well, this gets broken down into oxygen and an oxygen atom. Is that oxygen atom very happy? Nope. The ozone will recombine. It'll recombine. Mm-hmm. So this, the UV light causes this reaction to occur, but then the oxygen and the oxygen atom recombine to form the ozone. So what's the problem? Well, the problem is that some of the compounds that we have made as humans, like the chlorofluorocarbons, they go up and get up there in the upper atmosphere, and they mess this up. They mess up this reaction. And so that's why we stopped using them. And the effects of that are, I think, just beginning to be seen. The ozone layer is recovering. Any other questions? I'm not going to test you on that. I just think it's interesting.